Hello and welcome dear students. Today we will delve into an important lecture on topic hydrological hazards, floods and droughts. Hydrological hazards are the event related to water and its movement on surface of the earth, resulting interaction between meteorological factors, the hydrological cycle and aggravated by human activities. Floods, droughts are the main example of hydrological hazard. Flooding occurs due to the interplay of natural processes and human activities, often exaggerated by climate variability and environmental changes. Now, we will take a look into human actions impact on hydrological hazards. First is urbanization. Change in land use such as increased impermeable surfaces which reduces natural water infiltration leading to higher flood risk. Hydrological hazards present a growing challenge under the dual influence of natural variability and anthropogenic factor. Addressing these require interdisciplinary collaboration, technological innovation and proactive management strategies. Now, let us discuss the hazard one by one. Floods are situations arising out of inundation land due to river overflow or riverbank breaches, due to heavy rainfall holding up over a certain duration or rapid snow melting, dam failure and obstruction of river channel and the coastal storm surge. Floods result in damage to infrastructure, economic losses, casualties and public health issues and disruption of ecosystem. Around 40 million hectares of land are flood prone in India. The floods are largely concentrated in major river basins like Ganga, Brahmaputra, Meghna, affecting vast areas in northern plains of UP, Bihar, West Bengal, Assam states due to heavy monsoon, while east coast region faces cyclones and peninsular rivers such as Narmada, Tapti faces flash flood. Now, we will look into the causes of floods. Flooding occurs due to the interplay of natural processes and human activities, often exaggerated by climate variability and environmental change. Heavy and prolonged rainfall spread over the prominent area is the most common cause for flooding. High winds and low atmospheric pressure associated with cyclones, hurricanes or typhoons lead to heavy rainfall, causing coastal flooding. Seasonal temperatures increase the melting of snow, which can lead to substantial runoff into stream, sparkling riverine flow. Rise in intensity and frequency of heavy rainfall events globally due to the climate change often result in cloudbursts and thunderstorms. So, rivers with large volume of water experience overflow during period of intense upstream rainfall or dam breaks. So, increased impervious surfaces such as roads and buildings reduce water infiltration and increase runoff, contributing to urban floods. Removal of vegetation disrupts the water absorption capacity of soil, leading to increased surface runoff. Deforestation disrupts the water cycle, increasing surface runoff and soil erosion, which contribute to floods and landslides. An increase in extreme weather events such as intense rainfall and prolonged droughts has been directly connected to global warming. Rising sea level leads to storm surge and coastal flooding. At times, landslides obstructing the stream course lead to temporary damming of river course and subsequently causes flooding. Collapsed dams and levees can release huge quantity into the adjacent areas. Drainage system obstruction, poorly managed drainage system or blocked waterways can exaggerate the risk of urban floods. Now, let us discuss different types of flood. Floods are classified on the basis of their origin, and causes. Now, let us discuss these types of floods. The first one is riverine flood. Heavy and prolonged rainfall over an area can lead to riverine flooding as the land becomes saturated and water overflows the banks of the river. Intense rainfall for a longer duration and on big watershed areas and or snow melt water lead to river swelling in tributaries, building slowly water level in the trunk stream, that is the main river, leading river overflowing in adjacent areas, that these are the floodplains. So, the river bank breaching that continues for few days also lead to flooding of the floodplain areas. Seasonal increase in temperature at times induce snow melting, which further leads to substantial runoff into stream, sparking riverine flow. Now, another type of flood is coastal floods. These floods take place because of cyclones. Cyclones are the weather phenomenon generated over oceans in which winds move in an anti-clockwise manner in northern hemisphere that bring rain and also drag oceanic water in the coastal area, causing catastrophic floods due to storm surge. Tsunamis combined with high tides or sea level rise also affect low-lying coastal regions, causing sea water to rise abnormally over the land, leading to coastal flooding. The third type is flash flood. The cloudbursts, heavy rainfalls, tropical cyclones, dam breaches or even the river obstruction lead to flash floods. They are the events taking place within 6 hours time. During flash floods, large volume of water gets suddenly released, leading to rapid flooding events that are dangerous due to their unpredictability and speed. The another type of flood is urban flood. This type of flooding is associated with heavy rainfall, mostly in urban areas, and turns street into swift moving rivers. Urbanization lead to increased impervious surfaces such as roads and buildings that further reduces water infiltration and increase runoff. Contributing to urban floods as drainage system fails to manage excessive rainfall due to impervious surfaces or poor infrastructure planning. The another type of flood we have glacial lake outburst flooding. The rapid melting of snow and glacier in mountain areas like Himalayas lead to formation of temporary lakes called glacier lakes due to the damming by the moraines. The breach or sudden collapse of these lakes lead to abrupt release of heavy volume of water and debris, causes flooding in the downstream areas, that is known as GLOF. The another type of flooding can be done by ice jams. Ice jams are the situations when ice floating in a stream with huge masses at any place causes obstruction in the flow, thereby causing floods. These phenomena are associated with glacial melt linked with global warming and climate change. The another type is pluvial flood. These are caused by heavy rainfall that cannot be absorbed by the ground or drainage system, similar to urban floods, but on a large scale. Now, let us have a look into different impacts of flood. Flood impacts are multifaceted, affecting various aspects of the environment, economy and society. The impact of floods depends on characteristics of the flood event such as the depth of water, duration of the flood event, flood velocity, flood frequency and seasonality. Building foundation, other structures, crops and vegetation behave differently to different depths and flood durations. River flowing swiftly may cause erosive forces that damage bridges and river banks, leading to breaching of the banks. Flood water also erode soil and increase sedimentation into rivers and lakes, altering ecosystem leading to land degradation. Floods leading to habitat destruction for aquatic and land species, reducing ecological resilience and loss of biodiversity. Infrastructure, agriculture and land frequently suffer severe damages, incurring high losses. Flooding disrupts farming, fisheries and industrial operations, leading to sustained economic hardships. Stagnant floodwater can lead to outbreak of diseases such as cholera, malaria. Sudden or severe floods aggravate at times mental health issues like traumas, anxiety and depression in affected communities. Now, let us have a look into different pathways for flood mitigation. Flood is considered as the most damaging hydrological hazard, presenting complex challenges owing to its widespread occurrence, varied causes, multifactor impacts and diverse management approaches. Effective flood management requires an integrated approach encompassing prevention, mitigation, preparedness, response and recovery. Few of the key approaches proposed by investigator includes a restoration of wetlands and forests to enhance natural water retention and reduce runoff, urban floodplains as safe overflow zones designated for flood resilience. Advanced hydrological models integrate rainfall, runoff and soil saturation data to improve early detections and minimize impacts. Climate resilience infrastructures and effective risk communications are pivotal. Participatory frameworks involving communities are increasingly emphasized. Restricting construction in flood-prone areas through zoning laws can reduce human exposure to risk. Building levees, flood walls, retention basins and storm water drainage systems to contain excessive water. Technologies like remote sensing and GIS help monitoring and map flood-prone areas to enhance flood forecasting. Real-time flood detection based on meteorological and hydrological data allows timely evacuation and disaster risk reduction, involving communities in identifying and addressing flood risk and ensuring community preparedness. Restoration of natural flood buffers such as wetlands, forests and mangroves that reduces flood severity and create green spaces in urban area, which are the areas dedicated to flooding during overflow events. Now, we will have a look to floods early warning system in India. With over 12% of land which is vulnerable to different types of floods, India stands one of the high vulnerable flood countries in Asia. In recent times, India has significantly invested in the field of flood early warning system. India has designated Central Water Commission as the nodal agency for flood forecasting and warning. It has near 400 forecasting stations across the country, monitoring major rivers and issuing alerts based on real-time data. Central Water Commission utilizes telemetry based river gauge stations, satellite data, Doppler weather radars and hydrological models to predict riverine floods. Warnings and communicated to states and district authorities via SMS, email, web portals and integrate public alerting system. Central Water Commission collaborates with other nodal agencies such as IMD, NDMA, SDMAS for last mile communication, community engagement and evacuation plans. Now, let us have a look to the another hazard, that is drought. As drought are considered a phenomena that arises when area experiences prolonged period of significant water shortage. Droughts result from below average precipitation and or excessive evapotranspiration mismanagement of water resources, overuse of groundwater, Drought represents one of the most significant climate related challenge driven by complex natural and anthropogenic factors. Droughts globally are concentrated in the subtropics and mid latitudes, with major hotspots in Amazon, Sahara, India, Central Asia, Mediterranean and parts of North America. Droughts affect around 68% of the cultivable land in India, concentrated in western and peninsular India, especially Rajasthan, Gujarat, Maharashtra, Karnataka, Andhra Pradesh and parts of MP and Odisha, primarily in arid and semi-arid zones with low rainfall. Being a slow onset hazard, droughts differ from other natural hazards such as cyclones and floods in terms of its occurrence, as well in terms of its management and response. Its onset and end time is hard to ascertain. Also that no single indicator can identify precisely the onset and severity of the event and its potential impacts. Multiple indicators are more effective. The impact of drought are broadly non-structural in nature, such as reduced agricultural yield, water scarcity for humans and ecosystem, desertification, migration and economic losses, and difficult to quantify. Now, we will look into the causes for drought. The causes of drought encompasses both natural phenomena and human activities as encompassed below. We will discuss some of the natural factors. Shifting in atmospheric circulation pattern can significantly reduce precipitation in certain regions, for example, El Nino Southern Oscillation. Events are recurring large scale weather phenomena associated with Eastern Pacific region have been related to severe droughts in part of Africa and Australia and Southeast Asia, which faces severe rainfall reduction leading to drought conditions, increasing atmospheric greenhouse gas concentration, exaggerate temperature driven evaporation, modifying hydrological cycle and intensifying drought frequently and severity globally. Changes in meteorological parameters such as persistent high pressure system inhibit cloud formation and rainfall by blocking most airflows. This can occur seasonally or extended over multi-year period, inducing severe droughts. Land use change such as deforestation and urbanization can reduce soil moisture retention, further worsening drought conditions. Geological and hydrological factors at times contribute to the drought occurrence. For example, regions with thin or impermeable soil layers or poorly recharging aquifers and are more prone to severe water deficit during precipitation shortfall. Some of the human activities which enhance the drought: over extraction of freshwater resources for agriculture, industry and urban use strains water availability, aggravate drought impacts. Agricultural mismanagement such as excessive irrigation or water intensive crop selection can amplify drought vulnerability, leading to the water scarcity. Unsustainable groundwater extraction for agriculture, urban extraction and industrial practices significantly deplete aquifer, reduce the resilience of ecosystem to meteorological droughts. Monoculture farming, water intensive crop selection and inefficient irrigation amplify soil water deficit and regional drought potential. Large scale water impoundments can delay hydrological responses or exaggerate drought propagation dynamics in downstream areas of reservoir in arid river basin. Now, we have different types of drought. Droughts are broadly classified into 4 main categories, each reflecting different impacts and processes. The first one we discuss is meteorological drought. So, meteorological drought is defined by a prolonged period of below normal precipitation in a given area relatively to the climatic average. Meteorological drought generally occur prior to other kinds of droughts. A meteorological drought is said to have taken place when seasonal rainfall received in an area is less than 25% of its long term average value. It is further classified as moderate drought if rainfall deficit is between 26% to 50% and severe drought when deficit exceeds 50% of normal rainfall of that region. The another type we have is agricultural drought. Agricultural drought is usually set off by meteorological and hydrological drought and occurs when soil moisture and rainfall are inadequate during the growing season. The deficiency of rain then causes crop stress, often to wilting of the plants. Agricultural droughts in India is defined as period of 4 consecutive weeks with a rainfall deficiency of more than 50% of their long term rainfall average, or with a weekly rainfall of 5 centimeter or less from mid May to mid October, when 80% of the India's total crop is planted, or 6 such consecutive weeks during the rest of the year. Now, we have another type, that is hydrological drought. This type of drought is associated with reduced water level in rivers, lakes, reservoirs and aquifers. It follows the meteorological drought due to time lag to hydrological responses. It is generally assessed as deficiencies in surface and groundwater supply, leading to scarcity of water. Then we have socio-economic drought. This drought arises when water scarcity disrupts economic activities, public health, social system. It contemplates the convergence of natural water deficit and human dependency of water resources. Now, let us have a look on the impacts of drought. Drought impacts mostly environment, economies and societies in different ways. On environmental front, droughts increase desertification and lead to loss of land fertility. Droughts lead to reduction in moisture quantity of soil, which also lead to plant water stress, irritating the plant and vegetation health. For example, long term drought situation in China's northwest region, for instance, have accelerated vegetation degradation and desertification. They cause loss of biodiversity due to habitat degradation and reduced water availability. Droughts further lead to decline in vegetation, health, wildlife habitats are degraded as water and food sources become scarce. Species reliant on freshwater ecosystem are disproportionately affected, leading to imbalanced ecosystem. Degradation of water resource manifest as significant reduced water level in rivers, lakes and reservoirs. Groundwater recharge rates diminish, creating cascading effects on dependent ecosystem. Now, let us have a look on the monitoring and management of droughts. Integrated water resource management, that is IWRM policies for sustainable groundwater and surface water use, supported by reservoir, infrastructure and water conservation technologies in agriculture such as drip irrigation, are crucial for reducing the water stress and drought. Developing drought resistant crop varieties and diversifying crop pattern to enhance resilience. Using statistical models that integrate climate and environmental data to anticipate agricultural drought, and using remote sensing data such as MODIS for drought monitoring. Reforestation and maintaining healthy watershed improve soil moisture retention and reduce susceptibility to droughts. Now, early warning system for droughts. India as a country is highly vulnerable to hydrological hazards like droughts, has taken necessary initiatives for monitoring of droughts and developing of early warning systems are as IMD drought monitoring. So, IMD, Indian Meteorological Department, monitoring rainfall anomalies and issues drought advisories, based on indices like Standard Precipitation Index and Rainfall Deviation Maps. National Remote Sensing Center using satellite derived soil moisture, vegetation indices and water body extents. NRSC provides drought monitoring and early warning system. Central Groundwater Board monitoring groundwater levels and issue warning about declining water table and drought risk. Drought Early Warning System is an integrated platform that combines meteorological, hydrological and remote sensing data to assess drought risk and disseminate alerts to government agencies and farmers. Now, trends in floods and droughts in India. Floods and droughts in India is one of the most urgent hydroclimatic challenge. These two extreme events are occurring in close succession or even concurrently across different regions of country due to the erratic behavior of Indian summer monsoon ISMR, which as per the reports governs approximately 70 to 90% of annual rainfall. Recent studies have demonstrated that frequency and severity of both hydrological extremes have increased over decades, with profound implications for water security, agricultural productivity, socio-economic development. The spatial and temporal variability of monsoon rainfall has become more pronounced, leading to situations where some states experience catastrophic flooding while others simultaneously suffer from severe drought conditions, a phenomena directly linked to a large scale atmospheric teleconnections such as El Nino Southern Oscillations and Indian Ocean Dipole, as evidenced by the research. One of the example is 2002 monsoon drought that affected 56% of India's geographical area, impacted 300 million people, leading to 33% reduction in storage across 70 major reservoirs and caused an estimate $8.7 billion in crop loss. It has been calculated that this event damaged paddy and cotton crops in Haryana, devastated 16 lakh hectares in Karnataka, resulted in total kharif crop losses exceeding rupees 44,000 crores in Rajasthan. Such widespread impacts highlight the systematic risk posed by meteorological droughts, which propagate into hydrological and agricultural droughts, disrupting flood system and rural livelihood. Conversely, flood events often triggered by short durations, high intensity rainfall associated with cloudburst, cyclonic system, glacial lake outburst flooding are becoming more frequent and destructive, particularly in urban centers and mountain regions. The 2018 Kerala flood, among the worst in century, submerged vast area due to unprecedented rainfall, highlighting the limitation of existing drainage infrastructure and early warning system. Urbanization, deforestation and encroachment upon floodplains have reduced infiltration capacity and increased surface runoff, transforming what might have been manageable rain events into disaster. So, this is all about the today's lecture. Hope you have enjoyed it. Thank you for watching.